Hello students, once again welcome you to GK's maths classes. Today this is the part 6 of the video on maxima minima word problems. I have put around 5 videos before where I have solved word problems from maxima minima, and the concept of maxima minima I have explained in part 1, which I will put in the description box for your reference. So we will not be wasting time in explaining the concept of maxima minima. Instead we'll solve some problems straight away. Okay, so I have few more questions to solve in maxima minima word problems, okay, which are, some of them are from the NCERT, some of them are not. Okay, so now this is a NCERT question. A rectangular sheet of tin 45 centimeter by 24 centimeter is to be made into a box without top by cutting off equal squares. There must be a word called equal squares from each corner and folding up the flaps. What should be the side of the square to be cut off so that the volume of the box is maximum possible? So let's have a rough diagram of what it is. So first let's take a rectangular sheet of tin. So this is a rectangular sheet of tin, and the dimensions are like he says, it is 45 centimeter by 24 centimeter. Now equal squares are cut off. So let's take equal squares. I'll just change this color to say red. So equal squares are cut. So 1, 2, 3, 4. So I'll take this and I'll put it here. Equal squares are cut. This is one part. This is the second part. This is the third square that is cut off, and this is the fourth. This is not equal. So 4 squares are cut off. See, all these are cut off. So, and this is a flap. You see, from here to here is a flap. These are the flaps. So these flaps are folded up. Okay, I will fold this flap up. I will fold this flap. I'll fold this. So there are totally 4 flaps. So if you fold them up, you get a box which is open at the top. Okay, it will be a cuboid. So what is the length of the box? So let's look at the length of the box. Length of the box. So before taking length of the box, I should know what dimension I'm going to cut. So I'm going to cut equal squares, so let the dimensions of the square be x. Okay, so what will be the length of the box? The length of the box will be 45 minus 2x. Why it is minus 2x? X on this side, x on that side, so 45 minus 2x. What is the breadth of the box? Breadth of the box will be 24 minus 2x. Why it is 24 minus 2x? It's 24, x on this side and x on the other side, so 24 minus 2x. What is the height of the box? So the height of the box will be x, because this is the flap that is folded and the width of the flap is x, so that will become the height of the box. Now what is volume of the box? Volume of the box is length into breadth into height, so it is 45 minus 2x into 24 minus 2x into x. This is just one variable. You can either use UVW and differentiate, or you can use product rule. So I prefer to, or I can just open the bracket. So I prefer to open the bracket. So it is like 45 into 24 will be like 1080. Okay, 1080x minus this will be like 90, and this is 48, right? So it will be 138x square if you open the bracket, and it will be plus 4x cube. 2x square into x is 4x cube. So I think you know how to open the bracket, just multiply. Now I am going to differentiate. So what is dv by dx? dy by dx will be 1080 minus 276x minus 12x square, sorry, plus 12x square. So now 12 is common. I get x square minus 23x, right? 23x plus 90. Plus 90. Okay, 12 goes. So this is 12 into x minus 18 into x minus 5 by factorizing this. Now I equate it to 0. I am finding the turning point. dv by dx is 0. So I get x is equal to 18 and x is equal to 5. Now x is equal to 18 is invalid because when x is 18, my breadth of the box, so look at the breadth of the box will become 24 minus 36, which is invalid. Breadth cannot be negative. So x is equal to 18 is invalid. So the only possibility is x is equal to 5. So this is the what should be the side of the square to be cut off. So side of the square to be cut off is 5. Okay, in fact 5 centimeters. Now how do I maximize? So I need to maximize the volume. So what I will do, I will take this and differentiate. So let's take dv by dx. dv by dx will be 12 into x square minus 23x plus 90. So I'm going to differentiate this. D square v by dx square. D square v by dx square will be 12 into 2x minus 23. Normal differentiation. So put x is equal to 5. So you get 12 into 10 minus 23. Obviously this is negative. Therefore V is maximum. The volume is maximum when x is equal to 5 centimeter. Isn't that what I have to prove? What should be the side of the square to be cut off so that the volume of the box is maximum possible? Okay, so it's a very important question. Now let's do a similar question, similar to the previous one. Okay, a square piece of tin. So here it is not a rectangular piece, it's a square piece. So a square piece of tin. And what are the dimensions of this? This is 18. And is made into a box by cutting off equal squares. Once again the word equal is missing. So we'll take it, we assume it's equal. So let me take it as equal. 2, 3, 4. The equal squares are cut off. Okay, I'm cutting it. So just give me some time. So equal squares are cut off. Let me take the dimensions of the square as x. So what will be the length of the box? The length of the box is, obviously it is 18 minus 2x. What is the breadth of the box? The breadth of the box is, once again, 18 minus 2x. What is the height of the box? The height of the box is x. So what I need to do, I need to maximize the volume of the box. So what is volume of the box? Length into breadth into height. So length into breadth into height. Now I'll differentiate. dv by dx, I'm going to use product rule. What is that? 18 minus 2x the whole square. Differentiation of x is 1 plus x into, what is differentiation of this? This is 2 into 18 minus 2x into minus 2. I'm using chain rule. First I differentiate the power, then I differentiate 18 minus 2x. Now here clearly you can see 18 minus 2x is common. So what do I get inside? 18 minus 2x minus 4x, which is 18 minus 2x, and it is 18 minus 6x. Now I find dv by dx is equal to 0, which will be x is equal to 9 and x is equal to 3. If x is 9, then you see the breadth of the box will become 0. 18 minus 2x, which is invalid. So x is equal to 3 is the correct value. Now I want to find the maximum volume. How do I maximize? I have to differentiate this again. So I'll take this and differentiate. What is dv by dx? dv by dx is 18 minus 2x into 18 minus 6x. So again I am going to differentiate. D square v by dx square. I am using product rule. 18 minus 2x, differentiation of 18 minus 6x is minus 6, plus 18 minus 6x into differentiation of minus 2x is minus 2. Now you put x is equal to 3, you get 18 minus 6 into minus 6 plus 0, because 6 3 is 18, 18 minus 18 is 0. So obviously this is negative, therefore V is maximum. When is it maximum? V is maximum when x is equal to 3 centimeters. Exactly like the previous question, only thing is in the previous problem a rectangle is given, here a square is cut on all four corners via equal squares. This is once again an NCERT question. All these three problems are from NCERT and they are all very reasonably important questions. A rectangle with a tank with a rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meters and the volume is 8 meter cube. If building of the tank costs rupees 70 per square meter for the base and 45 per square meter for the sides, what is the cost of the least expensive tank? Now he has given you a rectangular tank, okay? The tank which is having a square rectangular base and it is also having a rectangular sides. But he has also said, he has also given you two important things. One is, he has said the depth, the height of the tank is 2 meters, and he also says the volume of the tank is 8. So these two are given to you. Now, he also says it costs rupees 70 per square meter to make the base and 45 per square meter to make the sides. So he wants to know the cost of the least expensive tank. Okay, so let's see how we solve this problem. First of all, let me take a, I think we will get only a square, right? So I'll construct it, it's not a problem. So this is a box. So I have a box. Let me complete the construction first. I need 4 such things. 1, 2, 3. So I'll keep it here. So these are the rectangular box. Okay. So what is given to you? You have said the height is 2 meters. And the base I don't know, so I call it X. Height also, the side is also not known, so it is Y. And the total volume is given to you, right? So what is volume of the box? Volume of the box is 8, which is length into breadth into height. So from this you know xy equal to 4, which I call it as 1. Okay. Now I want to find the least cost. So what is cost? The cost function. I'm talking about the cost function. Now first I want to make the base. So what is area of the base? The area of the base is xy. The area of the base, the floor is x into y, right? But it cost 70 rupees per square meter for the base. It cost how much? 70 rupees per square meters. But what is the total area of the floor? It is xy. So 1 meter square is 70. So xy meter square will be 70 into xy. So this is the total cost for making only the floor, correct? Now I have to make the walls. Now I am going to look at the walls. Now first let's look at this wall. Look at this, okay, this wall. You know, the area of this wall will be length into breadth, that is 2x. But you see there are two such walls, one in front, one behind. Can you see it? One behind. So it will be 2 times x, that will be area of one wall, but there are two such walls, so 2 into 2x, correct? Plus, what is the area of this wall? The area of this wall will be 2y, but you see there are two such walls opposite to each other, correct? So this is the total area of the walls, but it costs rupees 45 per square meter to make the walls. So for 1 square meter it is 45. So how much is the? It will be 45 into this, correct? So what is the total cost? Total cost will be 70. Xy is 4, so I will put the xy as 4, and here 4 is common, so I get 180 into x plus y, correct? So total cost will be 280 plus 180 into x plus, what is y? Y is 4 by x. How did I get it? I got it from 1. Now differentiate. dc by dx. Differentiation of 280 is a constant, so it's 0. So 180 into differentiation of x is 1. Differentiation of 4 by x will be minus 4 by x square. Now the turning point, dc by dx is equal to 0. So I get x square equal to 4. You know x is the length of the box, so it can't be negative. So I don't take plus or minus, I take only plus 2. Now what is d square c by dx square? D square c by dx square will be 180 into differentiation of 1 will be 0. Differentiation of minus 4 by x square will be 8 by x cube. Correct? 1 by x square is minus 2 by x cube. So this is obviously positive because there is no negative here. Therefore C is minimum. So the cost is minimum. When is it minimum? When x is equal to 2. Okay. So I want to find the minimum cost. So I'll substitute here. So what is the minimum cost? C equal to 280 plus 180 into x plus 4 by x, which is 280 plus 180 into x is 2 and 4 by 2 is also 2. So C equal to 280. If you multiply, you get 180 into 4. So obviously C is rupees 1000. Okay, very simple NCERT question, not complicated, but you have to understand the problem and do it. Okay. Now let's go to the next problem. This is a very important and slightly difficult question also. So let's see. Find the point on the curve y square equal to 4x, which is nearest to the point. Okay. Now what is y square equal to 4x? Y square equal to 4x is a parabola. So I am not interested in drawing a perfect parabola. It's a parabola or some curve. So what is the equation of the curve? Y square equal to 4x. He is saying find a point on the curve. So I don't know where to find. So I'll choose a point. I'll choose the point P as, say, A comma B. Find a point on the curve which is nearest to. So nearest means closest. Which is nearest to the point Q, which is 2 comma 1. So basically I want to minimize this distance PQ. Okay. So what I will do is, first of all, you have P A comma B be a point on the curve. What is the equation of the curve? Y square equal to 4x. So definitely this point should satisfy this equation. Now how does it satisfy? You have B square equal to 4a. Call this as 1. B square equal to 4a. call it as 1. Now what do? I want to find the shortest distance. So I will take let PQ equal to L. I'll take PQ as L. So what is L equal to? L equal to square root of A minus 2 the whole square plus B minus 1 the whole square. I am using the square root. You can always square it and call it as K. So what is K equal to? A square minus 4A plus 4 plus B square minus 2B plus 1. Now clearly it has two variables. I want to change it to a single variable. Now how do I change it to a single variable? I will keep A square as what? Okay, I will write A square as B power 4 by 16 because my A will be B square by 4. So A square will be B power 4 by 16. My 4A will be B square plus B square minus 2B plus 5. I am adding 4 plus 1, that is 5. This can be cancelled. Now you can see clearly it has only one variable. The variable is B. So I find dk by dB, which is 4B cubed by 16. Differentiation minus 2B is minus 2. Now find the turning point. dk by dB equal to 0. So I get B cube by 4 minus 2 equal to 0. B cube equal to 8. Therefore B equal to 2. Okay. Now what do? Find d square k by dB square. Why do I do second derivative? To check whether it is maximum or not. So I'm going to differentiate this. So what is that? This will be 3b square by 4, correct? 3b square by 4. Differentiation of 2 is 0. So obviously this is positive. Therefore k is minimum. When is it minimum? When b is 2. If k is minimum, L square is minimum. If L square is minimum, L is minimum. Correct? That is what you want to do, right? Shortest distance between P and Q. Now when B is 2, what is A? 4 equal to 4A. Therefore A equal to 1. So what's the point? The point should be 1, 2. So 1, 2 is a point on the curve which is nearest to 2, 1. Simple, but very, very important type of question. Okay. Okay. This is similar to the previous one, but it becomes a little bit more complicated because of this plus 2. How it gets complicated, we will see. Now, what is the question? An aeroplane is flying along the curve y equal to x square plus 2. I have to find a point on the curve, okay, which is nearest to 3, 2. Okay, so that's the question. In just I've told you. So this is a curve, and the equation of the curve is y equal to x square plus 2. A soldier is placed at 3, 2. So what is the shortest distance between the soldier and the jet? So let us assume that when the jet comes here, what is this point? I don't know. So I call it A, B. Then at this point, the soldier will be very close to take a shot. So what is the position of the soldier? The position of the soldier is 3, 2. Once again, I have to minimize this distance. Just like the previous problem, this is not complicated. But because of that plus 2, your calculation becomes a little difficult because you may encounter a cubic equation. Let's see. Let P A, B be a point on the curve. So what this point will do, it will satisfy the equation. How does it satisfy? B equal to A square plus 2. Call this as 1. b equal to a square plus 2, so call it as 1. Now what do you do? I want to minimize this distance, so I call it as L, which is PQ. So what is L equal to? Root of a minus 3 the whole square plus b minus 2 the whole square. Distance formula. It has two variables plus there is a square root. So as usual, I follow this trick of squaring it and calling it as k. So k equal to a square minus 6a plus 9 plus b square minus 4b plus 4. So k equal to, what is a square? One second, b square. Okay, a square I'll keep it as it is. 6a also I'll keep it as it is. My b square I will write it as a square plus 2 the whole square. And my 4b will be 4 into a square plus 2. And 9 plus 4 is 13. Now everything is single variable, but I prefer to simplify it first. So this will be a square minus 6a plus a power 4 plus 4a square plus 4 minus 4a square minus 8 plus 13. So 4a square cancels. So what is k equal to? A power 4 plus a square minus 6a, and this 4, this would come minus 4 plus 9, correct? This is minus 4, so it becomes plus 9. Okay, great. Now I got it in single variable. Now differentiate. dk by dA. How do I differentiate? This will be 4a cube plus 2a minus 6. Okay. Now equate it to 0. dk by dA equal to 0. So it becomes 2a cube plus a minus 3 equal to 0. I cancel the 2. Okay. Now if you see, a equal to 1 will satisfy this. A equal to 1 is a root. So I want to find the remaining factors. So how do I do? Synthetic division. 2, a square is missing, so I put a 0. A will be 1, its coefficient. Constant is minus 3. Since 1 is a factor, I start with 1. Begin with 0. Inside you add, outside you multiply. 2 plus 0 is 2. 1 into 2 is 2. Again you add, 0 plus 2 is 2. 1 into 2 is 2. Again you add, 1 plus 2 is 3. 1 into 3 is 3, and it very well satisfies. So this will be a minus 1 because 1 is a factor. And what is the remaining? 1 powerless. 2a square plus 2a plus 3. A minus 1. Since it's a cubic equation, reduce the power by 1. So 2a square plus 2a plus 3. Now equate it to 0. So what do you get? You get a equal to 1, and you get 2a square plus 2a plus 3 equal to 0. Now I want to see whether it's possible for me to solve. So what I will do, I'll test it with my discriminant. When I test with the discriminant, what happens? 4 minus 4 a c, which is negative, so it has no real roots. If it has no real roots, this is invalid. So only possibility is a equal to 1. Now go to the second derivative. Why do I go to the second derivative? To check whether L is minimum or not. 12a square plus 2. You know 12a square is always positive for any value of a. Therefore this is positive. Therefore k is minimum when a equal to 1. If k is minimum, L square is minimum. If L square is minimum, L is minimum when a equal to 1. So when a is 1, what happens to b? Substitute here. you get 1 plus 2, therefore b equal to 3. So the point on the curve should be 1 comma 3. So when the jet comes at 1 comma 3, it will be nearest for the soldier to shoot at the aircraft. Okay, it's a simple question. This type of questions can be put in case study also. Okay, the next one is a very important question. This is not from the NCERT book, but it has come in the board exam also. This is from some other book. Let's see. A rectangle is inscribed in a semicircle. A rectangle is inscribed in a semicircle of radius r with one of its sides on the diameter of the semicircle. Find the dimensions of the rectangle so that its area is maximum. Also find the area. So, what is inscribed inside? A rectangle is inscribed. So, everything about the rectangle is a variable. Inscribed inside what? Inside a semicircle. So, everything about the semicircle is a constant. Okay. So, first let's begin and see whether we can draw a semicircle. So, do I have a semicircle? I don't think I have a semicircle. So, it's okay. We'll draw a freehand diagram. Okay, this is a semicircle. What happened to this? This is a semicircle, and this is the center of the semicircle. Okay. Now I'm going to inscribe a rectangle. So I'll use a rectangle. See how I'm inscribing it? This is how you inscribe a rectangle. Okay, how do I inscribe the rectangle? With one of its sides, look at this, with one of its sides on the diameter. So one of the side is on the diameter of the semicircle. Correct? So let me name the semicircle as A, and this is B, this is C, this is D. This is the radius of the circle. Okay. So let us take the length of the semicircle as length of the rectangle as 2x and the breadth as y. Now why do I choose it as 2x? So that I can have OB as x. If I choose AB as x, then I have to choose OB as x by 2. Fractions little difficult, so I don't want to get into that. Okay. So area. What is area formula? The area of the rectangle will be length into breadth. Length into breadth. Now clearly you know r is a constant. Everything about the semicircle is a constant. So let's see how to go about it. This is x and this is y. Now using Pythagoras theorem, what do I get? I get 2x into y will be r square minus x square, correct? Y will be r square minus x square using Pythagoras theorem. Once again, there is a square root. I want to get rid of it by calling it as k. So what is k equal to? 4x square into r square minus x square. It has one variable x because r is a constant. So 4 is outside. What do you get? R square x square minus x power 4. Now differentiate. dk by dx, which is 4 into differentiation of r square is constant, x square will be 2x minus x power 4 will be 4x cube. Now dk by dx is equal to 0. So I get 2r square x equal to 4x cube. X gets cancelled and 2 also gets cancelled, so I get r square equal to 2x square. Therefore r will be root 2x. Or you can say x is equal to r by root 2. In fact, this is the way you should write, because he has asked for the dimensions of the rectangle. So dimensions means 2x, right? Length is 2x, so it will be 2 into r by root 2, which is root 2r. So that finishes this part. Now, how do I know the area is maximum? Second derivative, d square k by dx x square. So I'm going to differentiate this fellow. So 4 is a constant, 2r square is a constant, differentiation of x will be 1, minus x cube will be 3x square, already there is a 4, so it is 12x square. This is 4 into 2r square minus 12 into, what is x square? X square will be r square by 2. So it becomes 6. So 2r square minus 6x r square will be negative. Therefore, k is minimum. When is it minimum? When x is equal to r by root 2. If, I'm sorry, negative means maximum. Okay, sorry. Maximum. If k is maximum, a square is maximum. If a square is maximum, a is maximum when x is equal to r by root 2. Or you can say when 2x is equal to root 2r. Okay. Now I want to find y. How do I find y? You know, x square plus y square equal to r square. Now what is x square? X square is r square by 2. So what is y square equal to? R square minus r square by 2. Therefore y square will be r square by 2. Therefore y will be r by root 2. So what are the dimensions of the rectangle? Root 2r, that is the length, and the breadth will be r by root 2. Now the question is to find the maximum area. What is the maximum area? Length into breadth. If you multiply, you get r square. Okay. So fairly simple question, but you have to think and do. It's not that direct, but sometimes getting the diagram is difficult. Now this is the last problem for the day, and this is again a very, very important question. Okay, this is what? A given quantity of metal is cast into a half cylinder with a rectangular base and semicircular ends. Okay. What should be, okay, in order that the total surface area is minimum. The ratio of the length of the cylinder to the diameter of the semicircular ends is pi is to pi plus 2. Something is missing. Okay. Okay. So basically I want to minimize the total surface area. Okay, so let's draw the diagram. This is a half cylinder. See, I am drawing the half cylinder. It has a rectangular base. Okay. And semicircular ends. It has rectangular base and semicircular ends. So half of a cylinder. Okay. Now I will take the length of the cylinder to be 2r, which is the diameter, and the breadth to be height of the cylinder. Yes, sir, given quantity of metal. What do you mean by given quantity of metal? Volume is given to you. What is volume? Pi r square h by 2. Why by 2? It's only half of a cylinder. All this as one. Please remember, V is a constant. V is a constant. Now should I maximize or minimize? I have to minimize. Minimize what? Total surface area. So what is total surface area? So let's go one by one. The total surface area comprises of this base, the rectangular portion. So what is area of the rectangular portion? The area of the rectangular portion will be length into breadth. Am I right? Length is 2r, breadth is height. So I have completed this rectangular portion. See, this rectangular portion area is covered. So this area is calculated already. Now it has two semicircles. So when you put two semicircles together, you get one single circle. So I will call it as pi r square. So I have exhausted this area also. Correct? This area is also exhausted. And I have already exhausted the rectangular portion. Now the curved portion. The curved portion is not included. So what is Csa of a cylinder? 2 pi RH. Since it's a half cylinder, you have to divide it by 2. I hope you understand this equation. This is very difficult. Okay. First, the rectangular portion, that is 2r into h. Then the semicircular portion, that is pi r square. Then the curved surface area, that is 2 pi r h by 2. Now clearly, if you notice, it has two variables, r and h. I'm going to change it to a single variable. How? First, I keep pi r square as it is, this one. Now here what I do, I take out common. What is common in this? R is common. So I get pi plus 2 into h. You see, r is common. Pi plus 2, h is also common. So now S is equal to pi r square plus r into pi plus 2. What is h? H is nothing but 2v by pi r square. This I get from 1. From 1, h is 2v by pi r square. So r can be cancelled. Now if you notice, it has only one variable. So what is ds by dr? ds by dr will be 2 pi r minus pi plus 2 into 2v by pi. Why did I put minus? Because differentiation of 1 by r will be minus 1 by r square. Differentiation of 1 by r will be minus 1 by r square. Okay, so differentiation is done. Now I'm going to find the critical point. ds by dr equal to 0. When I put ds by dr equal to 0, what do I get? I get 2 pi r equal to pi plus 2 into 2v by pi r square. Clear? Now we can cancel this 2 and cross multiply. You get pi square r power 4 r power 3 equal to v into pi plus 2. Very interesting result. Let it be there. Now what do you do to check whether it's minimum or not? I want to take this and do second derivative. D square s by dr square. What is that? 2 pi r differentiation will be 2 pi, and this will be minus pi plus 2 into 2v by pi. 1 by r square differentiation will be minus 2 by r cube. So minus of minus becomes plus 2 by r cube. So it will be 2 pi plus, this will be 4 v pi plus 2. Okay, and actually I can make it a little easier. What I will do, okay, it will be like that. So it is 4v into pi plus 2 divided by, you know, pi r cube will be v into pi plus 2 divided by pi. So I'll put the pi up. Pi r cube will be v into pi plus 2 by pi. That I am substituting here. So v gets cancelled, pi plus 2 gets cancelled. So you get 6 pi, which is positive. Therefore, S is minimum. When is it minimum? When pi square r cube equal to v into pi plus 2. Now what I will do, this is pi square r cube. What is v? Half pi r square h from 1. And this is pi plus 2. So clearly you can cancel the pi. So you get 2 pi r. Pi gets cancelled, r square gets cancelled. You get h into pi plus 2. Okay. Now what you do? You have pi by pi plus 2 equal to h by 2r. Now what does h stands for? H stands for the length of the cylinder. Length of the cylinder is nothing but the height of the cylinder. and diameter of the cylinder is nothing but 2r, and the ratio of the length of the cylinder to the diameter, I want to prove it as pi is to pi plus 2. That is exactly what I got. So I hope this is clear. It's a little difficult question. I hope it's clear. You can always go through it. And if you have any doubt, kindly put your doubt in the comment section. I will definitely get back to you. Kindly subscribe to my channel and click the bell icon to get notifications of video that I post. Hope these videos are very useful to you. See you again in the next class. Have a lovely day. Bye-bye.